Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem. So in today's problem, we'll be given two matrices, right? Mat1 and mat2. And what the problem is saying is the numbers in the matrix will be sorted, right? So if you see 1, 5, 6, and also the last element of a row, right? The last element of the row would be lesser than the first element of the next row, right? In this way, the matrices are sorted. Okay, if you have a look. Okay. Now what they're saying is will be given a target value, right? That is x equal to, for example, let's say x equal to 21. This is a target value. Now what we want to do is we want to find the count of we want to find and count all pairs A and B, all pairs A B whose sum is equal to whose sum A plus B equal to x. Okay, equal to x. And the condition is A should be from mat 1, right? And B should be from mat 2. Okay, we have to find all such pairs, right? Whose sum is equal to the target value. Now, in this case, right, in this example, there are how many pairs? There are 4 pairs. Okay, how? So one is 1 and 20, right? 1 plus 20 equal to 21, right? Target value equal to 21. 1 plus 20. See, 1 is coming from matrix 1 and 20 is coming from matrix 2. So it satisfies the condition, right? The other pair is what? 5 and 16. 5 from mat 1, 16 from mat 2, right? The other pair is 8 and 13. 8 from mat 1, 13 from mat 2. Other pair is 11 from mat 1 and 10 from mat 2. Okay, so these are the 4 pairs. Okay, these are the 4 pairs. Okay, so now I hope you've got the problem. Now, first, how can you solve the problem, right? So what we can do is, first let's see. Okay, and one more thing, the time complexity is O of n square and space complexity is O of 1. Expected space complexity is O of 1. Okay, now first let's see the brute force approach, right? How we can solve this problem. So what we can do is we can take a set. Okay, we will take a set, right? We'll take a set and we will iterate through the first matrix, right? To the first matrix, right? And what will be the time complexity? Int I equal to 0 to n, right? And for j equal to 0 to n, right? And we'll just simply insert, right? Insert or add, right? Into this set, right? Into this set. Okay. Once it is done, once the set is filled with all these elements mat 1, the second step would be to iterate through this mat 2, right? Again, the same for I equal to 0 to n, right? Iterate through the mat 2, j equal to 0 to n. And what we'll do? We will try to find, right? For example, set dot find, for example. Let's say there's a function, right? We'll find if x minus mat 2 of ij is present or not, right? For example, x is what? 21, right? Now we are coming here, for example, 20, right? So mat of ij is 20, right? We had inserted all these elements, right? 1, 5, 6. Now what we are doing is x21 minus mat 2 of ij, right? That is 20. That what is which is what? 1, right? And we are finding in the set. So we'll find 1 in the set because we inserted 1, right? So in this way, okay, in this way, if we found the element, then we'll increment the count. We'll have a count variable, right? We'll increment the count, and then finally we'll return this count. Okay. Now, what is the time complexity here? It is O of n square, right? And what is the space complexity? It is O of n, right? Why O of n? Because we are taking extra space. That is set. We are taking set, right? But the expected time, it is matching the expected time complexity, but the space complexity, expected space complexity is O of 1. Okay. And that is why we want to optimize the solution. Okay. Now, now let's see the optimized solution, right? So before going to that, I would request you to subscribe to my channel and like the video. Okay. So, uh, okay, let's come to optimized, right? Optimized solution, right? Now, what we're going to do is we are going to leverage the property, right? What they've said that the the elements are sorted. The elements are sorted in both the matrices, and the last element, right, of each row is lesser than the first element in the next row. Okay. Okay. So what we're going to so we are going to leverage this. So what we're going to do is simply uh we are going to I think I'll write the code. I'll write the code so that along with that in the code, I'll also explain. So first let's look the code. For what we are going to do, we are going to use a two pointers approach. Okay. We're going to use a two pointers approach. C1 equal to, for example, 0, right? And R2 equal to, now what we're going to do, we're going to take two pointer approach. That is, one pointer would be here, starting from the first element of matrix 1, and the second pointer, R2, C2, right, will start from here. Okay, we'll start from here. Now what we're going to do is, okay, let me first write the code R2 equal to, now what is the size of matrix n into n, right? So we'll C2 equal to n minus 1. Okay. So R1C1 is pointing to this element. R2C2 will start from this element. Okay. Now what we're going to do? We are now, since what? R1 is less than n, we'll go till R1 is less than n and R2, right? R2 is greater than equal to 0. Since we're starting from last row, right? For R2, for the matrix, if you see here, right? R2 is n minus 1, right? So we can go till 0, right? R2 when R2 is 0. Okay. Now what we're going to do? We are going to take the sum. right? mat1 r1 c1, right? Plus mat2 r2 c2, right? And also we'll take one count variable to count the number of pairs, right? 0, right? So here using here, right? We are taking the sum. What we're taking the sum? We're taking the sum of this. We're taking sum mat1 of r1 c1 and mat2 of r2 c2, right? We're taking the sum. Now we are checking if sum equal to what? X, right? If it is, then do increment the count. Okay, increment the count. We have found one pair, right? So now, since we found the pair, now we want to move ahead, right? To find the other pairs, right? So we'll move this, right? We'll increment the C1, right? The column will increment C1, column C1, right? And what we'll do, we'll decrement the column C2, right? Here, if you see, now we'll come to 5, and in this mat2 will come to 16, right? Okay. For example, now if the sum was not equal to x, right? For example, if the sum was lesser than, if sum is lesser than x, then what we'll do? If sum is lesser than x, for example, if here it would have been, let's say here it would have been 18, or maybe, yeah, maybe here it would have been 18, right? So what the sum would be? 1 plus 18, 19. So it would be less, right? Then this x equal to 21. So in that case, what we'll do, if the sum is x, that means will increment C1, right? We will go to, because the sum is less, right? So we want to increment the sum. We want to, right? We want to increase the sum, right? So we want to go to the higher number, right? Here, if we decrement C2, then we are going to go to the lower number. The sum will decrease further, right? So we'll go to the higher number, right? So that is what we're going to do. We are going to increment C1. Okay, we are in this case we're going to increment C1. Else, if sum is greater, then we want the lesser value of sum, right? So we will decrease. In this case, we will decrement C2, right? Because we want to move to the lesser element, right? We want to move to the lesser element. So minus C2. Okay, here we did this. Now what we're going to do, right? So it may happen that C1 has exceeded, right? Exceeded this n, right? C1 has exceeded this n, or C2 has become minus 1, right? Right? So what we're going to do, C1 equal to, if C1 equal to n, right? If it has exceeded, if C1 has become n, then what we want to do, will increment R1. We'll increment R1 and we'll make C1 equal to 0. So what we're doing, so since it has passed this, right? So simply what we're going to, we want to come to this element after 6. After 6, we want to come to this element, right? So what we're going to do, we are going to increment R1. R1 was here, we'll bring R1 here, right? We'll bring R1 here, and C1 also will make it 0, right? Similarly, if C2 equal to minus 1, right? If you have decremented, and right, if it has become minus, C2 has become minus 1, then in that case, what we're going to do, we are going to decrement R2, right? So here R2 was here, right? R2 was here, right? We have come here now. We have come here now. So what we want to do, we want to come to this element, right? We are moving like this, right? How we are moving? We are moving like this, right? We are moving like this, like this, right? Like this and like this, right? We're moving like this. So we want to come here, right? We want to come here. After this, we want to come here. So what we'll do, we'll decrement R2, right? And we'll also set C2 again to n minus 1, n minus 1. So decrement R2 and C2 set to n minus 1, right? N minus 1 we did, right? So, okay, these are the only changes. And what we'll do finally, we'll return the count, right? We'll return the count. Let me now compile this. Let's see if it works. Let me submit it. Yes, the solution is accepted. Let's quickly see the C++ code. It's almost same, right? See, I've implemented here. It's almost same. So only the thing is we have here vector of vector, right? And R1, C1. Okay, so it's almost the same, whatever I've explained. Okay, so I would request you to subscribe to my channel, like the video if you got the solution. Have a happy, healthy, and a great day. Thank you so much.